Next example, a cylindrical box. I'm going to draw that out. So it's a cylinder of diameter 12 and height 48. Is to be filled with spheres, just draw that out as well, of radius 6. Calculate the amount of space inside the box. Now, first of all, if you've got the radius of a sphere of 6, each sphere is going to be 12 in diameter, so you're going to fit 4 spheres in that box. So what I'm going to do is I'm going to have volume of cylinder, which is the area times the height. So it's pi r squared pi, and the radius is going to be 6 squared and the height is 48. So it's on the calculator, 6 squared times 48 gives me 1728 pi. I'm now going to work out the volume of one sphere, and the volume of a sphere is 4 over 3 pi r cubed, which is 4 over 3 pi times 6 cubed. So 6 cubed times 4 divided by 3 gives me 288 pi. And I want the volume left, the space left over. So the volume left is the whole cylinder minus, and we did say we could fit 4 of these spheres in, so 4 times 288 pi. So the way I worked that out accurately is to go 4 times 288, take that away from 1728 to give me 576 pi. I'll multiply the answer through by pi to give a proper answer. So 1809.6 centimetres cubed. Now I have 3 more examples left, and they're all to do with sectors of a circle. The length of an arc AB in a circle with centre O. So I'm going to draw out, that's your arc there. The radius is 15, and you're told this length of arc is 32. Now I want to work with that. The length of the arc is whatever angle you have, so say A for angle. So it's the fraction, the angle out of 360 gives you the fraction of a circle. This is the circumference, so it's pi times d. Still just going to work with this for a second. The length of the arc is 32. The angle I don't know. If the radius is 15, the diameter is going to be 30. Now I can use the information to work out my angle. Bring that 360 over in times. Bring your pi and 30 over and divide. Gives me my angle. So 32 times 360 equals, divided by, open brackets, 30 times pi, close brackets. Gives you an angle of 122.23 degrees. Now the question then is asking you for the area. Area. Let's think of what fraction we have. We've got 8 degrees out of 360. Area of a circle is pi r squared. I know my A degrees, 122.23 divided by 360 times by pi times by the radius, which is 15 squared. Now I have the answer in my calculator, so don't wipe it. Divided by 360 equals, times it by pi, times it by 15 squared, gives me an area of 240 centimetres squared. Number 18. The area of a sector of a circle which subtends an angle of 72 at the centre of the circle. Actually, it's a very fancy way of saying you've got a sector, its angle is 72 and the area is 8.9. So area of a sector is the number of degrees out of 360. That's your fraction you have, times it by pi r squared. So 72 out of 360 times pi r squared you don't know, but it equals 8.9. Rearrange this wee equation. Bring your 360 over so it multiplies. Bring your 72 pi over so it divides. So working that out, 8.9 times 360 equals, divided by, open bracket, 72 times pi, close brackets, equals 14.16. So r squared is 14.164. So your radius is the square root of that, which gives you an answer of 3.7636. Question says calculate the length of the arc in this sector. So the length of the arc is your fraction of your circle times by circumference. Keep looking for that bit there. So it's pi d. So 72 over 360 times pi times diameter is twice the radius. So just times that by 2, giving me 7.527. So in the calculator, times the answer by 72, divide it by 36, plus equals, and don't forget to times it by pi, gives you an answer of 4.729 centimetres. Now if that question asked you for the perimeter of that shape, you'd give that length there you've worked out, and then add on the 2 radii. And the last one I'm going to look at now is the perimeter and area of the shaded segment. The segment is that top part of a sector. Now, we've got the radius. We'll start off with the circumference part of it. Circumference of a circle. You don't have a circle, you've got a part of a circle, so work out what fraction you have. So 30 out of 360 degrees times pi d. So that cancels down to a 12th times pi, and your diameter is going to be 30. So your circumference is 30 over 12, which cancels down to 5 over 2 pi. So your perimeter is your 5 pi over 2 plus 15 plus 15. So altogether, giving that as a nice neat answer, you get 37.85 centimetres. The area of the sector, I'll write it out, area of sector. You've got 30 degrees out of 360, times it by the area of the circle, so that's 30 out of 360, times by pi, times by 15 squared, so it's 30 divided by 360 equals, times by 15 squared equals, so I've got 75 over 4 pi. I'll multiply that through neatly at the end. I need the area of my triangle here. Now remember, this is a radius, and that's a radius, so that's going to be 15 as well. The easiest way of doing this is to use your trig formula, the one that's half AB sine C. So it's a half the 2 sides times sine the angle between them. Just putting it into the calculator, 0.5 times 15 times 15 times sine 30 gives me an answer of 225 over 4. So the area of the segment, which is the shaded bit, is the sector 75 over 4 pi minus your triangle. Now put this into calculator, 75 times pi divided by 4 equals minus, and it's using your fraction button for the next bit, over 4 equals 2.65 centimetres squared.